Hi, Ariel. So, based on the two questions that you sent to the group, so I'm going to start with the first question, which is question number 13. And if you take a very good look at this question, it is clearly seen that we have a fraction right here, right? If you look at this, we have a fraction which is 1 divided by the fraction of 1 and x plus 2 with an addition of the fraction of 1 and x plus 2, right? And it is clearly given that if it's clearly stated here that if x is greater than 3, then we need to find an expression that is equivalent to this fraction. And I can gladly tell you that this question is actually based on simplification of what? Of fraction. So if you don't know how to simplify fractions, you find it very difficult solving this kind of question, okay? And I think the reason why you can't solve this is because I've not explained LCM yet. And that is the main reason why you can't do this. All right. Remember that I've actually explained GCF, right? You already know how to calculate the GCF between two expressions or two numbers. Now, that being I've explained LCM of two different expressions or two numbers, it will be very easy for you to solve this question. So, do you know what I'm going to do now? Ariel, I'm going to take my time to explain this question so that you understand it very well. All right. So, I'm going to start with this fraction and I'm going to simplify this fraction. To simplify a fraction means you want to break it down. You want to break down the solution, or you want to break down the fraction to the simplest form, right? And which means that I'm going to deal with this fraction. I'll write it here, and then this condition is just a condition given. Probably you not use it because you're not dealing with any inequality here. So it is just like a condition given, like x must be greater than 3. Because if x is not greater than 3, then this fraction becomes partly undefined. But we are going to simplify this first and see if the condition holds, right? So now I'm going to start with the fraction, which is 1. Okay, so we have 1, then we have a division sign, right? Which is the straight line here, and then we have 1 divided by x plus 2, then plus 1 divided by x plus 3. Now, I'm going to start with the solution now by saying whatever you have at the top part of this fraction happens to be the numerator, right? This is the numerator. And whatever you have down here is the what? Is the denominator, right? Which is the denom, right? You can write it for short. You can write it in short form like this, which is denominator, right? So if you can't identify the numerator and that of the denominator, right? This is the top part, which is the norm, and this is the down part, which is the denom, right? So now, to deal with questions like this, the first thing that you need to do is to break down the down part, because if you look at the top part of the expression, it is just a single value, just one, right? So I can't break down this one. This is the simplest value I can ever have. So this is just one, so I can't reduce it anymore. So but the down part can still be reduced. So I'm going to focus more on the down part, right? And which means that I'm going to write down one here, and then I'll still go with my straight line, which is the division sign. And you see, for this bracket now, what we have inside this bracket, it's actually based on addition of fraction, right? And I believe you remember how to deal with something like this: 2 over 3 plus, let's say, 4 or 5. Now if you are trying to add two fractions together, like if you are dealing with addition of fractions, remember that if you notice that the down part is not the same, like this is 3, this is 5, I have to make sure that the denominator becomes the same value, right? So I want the denominator to look alike, and then to achieve that, the first thing that should come to your mind is to verify if 3 is not divisible by 5. If 3 is actually divisible by 5, then you won't be able to use the normal method by multiplying the top part by something and the down part by the same thing. So since 3 is not divisible by 5, then I can rewrite this first term, which is 2 over 3, and then multiply it by whatever you have as the denominator in the second fraction, which is 5, right? And then you see for this one, which is 4 over 5, I can easily multiply it by whatever you have here, which is 3. And then it is clearly seen that we now have the same denominators for the fraction, such that we can then take this denominator as a single term and then go ahead and sum whatever you have at the top part, which is 10 plus 12, and then the final result becomes what? 22 divided by 15, which is very easy and direct. So I'm going to do the same thing here. Now it is clearly seen that x plus 2 and x plus 3 is just separate, right? It's on a separate form such that x plus 2 is not a factor of, that is x plus 2 is not divisible by x plus 3, just like what you have here, 3 and 5. So I'm going to do the same thing, right? And I'm going to use a square bracket for this, just a big square bracket, and I'm going to close it here, all right? Now, do you know what I'm going to do? Now, I'm going to write out this fraction, which is 1 divided by x plus 2. So I'm going to follow the same pattern, which says you have to multiply this 2 by 5, sorry, and I'm going to multiply this 1 by whatever I have on the right side of the term, which is just the denominator x plus 3. So I'm going to multiply this by x plus 3 and also multiply the down part by what? By x plus 3, right? And then you have a plus sign here, right? So now we have the second fraction, which is 1 divided by x plus 3, and I'm going to multiply this by what? Can you tell me? I believe you know what I'm going to write here, right? So that is just x plus 2. So I'm going to multiply this by x plus 2, and then you have what? Times x plus 2. Now it's making sense, right? So I can get rid of whatever I have here. So, but do you know that I actually mentioned LCM, right? So where are you going to apply the LCM of a fraction? Though normally when it comes to LCM, we used to find the LCM of two numbers, which is 3 and 5, and whatever you have as your LCM here should be 15. You know, there is a way we normally look for LCM, which I've not explained yet. But based on the fact that I already know how to find the LCM of two numbers, it is clearly seen that, like, I can easily see it that the LCM of 3 and 5 is 15. Now this is the right step of doing this. If you don't want to use the first method, this is the second method to use. And once you get to this point here, you are going to draw a long horizontal line and then write down the LCM, which is 15. And then the second step to take is to use this 15 to divide whatever you have as a denominator here, which is 3. Now 15 divided by 3, you are going to write your answer here, which is 5. Okay, so 15 divided by 3 is 5, and then you need to multiply it by whatever you have as the top number, which is 2. All right, and then you still have to go ahead with an addition sign. Now you still have to do the same steps for the other fraction. Now this 15 is going to divide 5. I'm going to divide it, and then you put your answer inside this bracket, which is 5 divided by 15 divided by 5 is 3, then times 4, right? Times the top number, which is 4. So this is the second method of solving addition of fractions, all right, which is the use of LCM. So I prefer this method most times because it works for any form of fraction that is being added together. So this is 5 times 2, which is 10, and this is 3 times 4, which is 12, then divided by 15, and then the result is 22 divided by 15, which is very, very similar to the previous method that has been used, which is the normal one that you know, right? So now if you apply this method for this question, it will be very easy for you to solve. For now, I'm using your method to solve this question by multiplying the top number by the denominator of the second term, and then do the same thing for the down part here, okay? And I'll do the same thing for the second term. Now this is what we've got, right? Which is 1 divided by 1 times x plus 3 is x plus 3, then you divide it by x plus 2, the product of x plus 2 and that of x plus 3, then you have to sum it with 1 times x plus 2 is x plus 2, then divided by x plus 3 and x plus 2. Now it is clearly seen here that we have the same denominators, right? Just like the way you normally do your fraction. So I can write this expression as 1 divided by. So now that they have the same denominators here, you know what to do, right? So I'm going to take it as a single term, which is x plus 2, x plus 3, right? So this is x plus 2, x plus 3, and this is x plus 3, x plus 2. I can write this thing as, when you have Noah times Ariel, I can write it as Ariel times Noah, right? It's still the same thing. So this is multiplying each other. So x plus 2 times x plus 3 times x plus 2 can still be written as, it's still the same thing as x plus 2 and x plus 3, right? It's still the same thing. Now they look the same. So I'm going to indicate a straight line here and then take these denominators as a simple term such that I'm going to add the top expressions together, just like we normally do your fraction, your addition of numbers, okay? Addition of fractions, sorry. So I'm going to sum this together, which is x plus 3 plus x plus 2. Now you see it's getting smaller, right? From a bigger expression, it's getting to reduce to a very simple term, as you can see, all right, compared to the way we have it before, right? So from here now, what can we do next? We just need to add these expressions together, these two brackets. So if I have these two together, which is 1 divided by, this is x plus 2, x plus 3 plus x plus 2, right? X plus 3. So I'm trying to open up the bracket. Plus times x is plus x, and then plus times plus 2 is positive 2, then divided by x plus 2, and then I have x plus 3. So it is clearly seen that we now have 1 divided by x plus x. You need to combine like terms such that x plus x is 2x, and then 3 plus 2, plus 3 plus 2 is plus 5, right? Then you divide this by x plus 2 and that of x plus 3. Now you see from a very big expression, on a very bigger expression now, it's getting smaller, right? You see that? That is what simplification of fraction is all about. You just need to reduce or break down the question given to you to the simplest step, right? So once you get to this stage, it is clearly seen that I can write this whole fraction as 1 divided by 2x plus 5 over x plus 2 x plus 3, right? And recall that I can easily switch this division sign to a multiplication sign such that the denominator goes up and then this top expression comes down, right? You're going to interchange them, which is x plus 2, x plus 3 divides 2x plus 5, right? I think we are getting closer to the final result from here. So this shows that we have 1 times everything here, which is still the same thing as x plus 2, x plus 3. You see, I'm trying to provide the step-by-step solution without skipping any steps. So I did not skip any steps here, so as you can see. So that is why this video is taking so much long. Alright. Now, from here, I can easily expand this. Just use the foreign method to expand this bracket, which is x is going to multiply x plus 3, and then positive 2 is going to multiply everything on the other side, divided by 2x plus 5, and then this becomes x times x is x squared, and x times 3 is 3x, plus 2 times x is plus 2x, and then plus 2 times 3 is plus 6, and then you divide it by 2x plus 5. So therefore, we are left with x squared plus 3x plus 2x is 5x, right? Then plus 6 divides 2x plus 5. And this is the final result for this question. I can't solve anything again. Alright, now it has been reduced to a single term in terms of fraction. So I'm going to check the option and see which of the option is actually equivalent to this. And I think that is option B. Can you see that? That is option B. So option B is correct, which is x squared plus 5x plus 6, then divided by 2x plus 5. Because this is the condition, you can only select numbers that are greater than 3. And numbers that are greater than 3 are 4, 5, 6, 7. So if you substitute 4 here, that is 2 times 4, then plus 5, which is 8 plus 5, and that is 13. For the top part of the expression, you can easily have something like 4 squared, which is 16, plus 5 times 4 is 20, plus 6, and this is 36, right? 36 plus 6 is 42 divided by 13, and 13 times 4, this is 12, this is 52. So I'm not sure if it is the same. All right, so it's not divisible, right? So the condition is not really necessary for this question. I think the main thing that you need to do here is to just simplify this fraction and detect which of the expression here is actually equivalent to this fraction, and that is just option, and that is option B. All right, since there is no negative sign at the down part, so we can't easily detect the undefined expression for this fraction. So B happens to be the final result of this, and you can try to verify from the textbook if option B is correct. And if it's not, kindly please reach out to me so I can verify that and look into the solution further. Is that clear? So that is for question B. All right. So I also have the second question. I think I've solved this one for you. I've solved this question before. Take a very good look at this second question. This one, right? I think I've solved this. Yeah. Yeah. I've solved this question before. Remember, it was this question I was trying to solve, and then you asked me that how did I manage to know what to do in the first place? This is 8x and this is 2 raised to the power of y. Then I said this 8 can be expressed as 2 raised to the power of 3. Then you still have x there. It was 2 times 2 times 2 is 8, and then this is 2 raised to the power of y. And it's clearly seen that this fraction here becomes 2 raised to the power of 3x divided by 2 raised to the power of y. And if I apply the law of exponent, which is for the division law, and this will definitely becomes 2 raised to the power of 3x. When you have a division, you subtract the powers together. So now I can easily see that of 3x minus y, and 3x minus y shows that it is equals to 12, right? That's been given. So the whole of this expression here is 12, and option A is correct. So I've solved this question before, all right? So real, that is basically how it works. And if you still have more questions, please feel free to send them to me so I can quickly create a video on it and forward it to you, all right? All right, so see you in the next class. Thank you. Bye. Take care.